Okay, here we go. Chapter 5, Section 6. Now, what you're going to see here is I discuss a couple things here. It's one way to organize information. Some of you guys are going to see a different way of doing it. By all means, if you see a quicker way and you want to do it that way, be my guest. It's just another option here. So, tree diagrams. It's going to be a way of helping us to understand or maybe organize our information. All know how to make tree diagrams. We've done a couple of those already, but just want to show you in relationship to this, but also show you how it can be done without a tree diagram already. So here's what we got going on. 2 urns. In the first urn, there's 4 black balls and 3 white balls, so a total of 7. The other one, there's 4 black, there's 7 white, and there's 2 red. So, excuse me, we got a total of 13 in the separate urns. Now, if you roll a 1 or a 2 on a die, you select from urn number 1. If you roll a 3 or higher, then you have to select from urn number 2. Based on those things, what's the probability that the ball is going to be black when you select it? Okay, so here's a couple different things we can do. I'll first start with the tree diagram. So we got to make a roll. You roll your die, 1 or 2 things is going to happen. You're going to get a 1 or a 2, or you're going to get a 3, 4, 5, or a 6. Okay? So there's how our tree starts off. So if we roll a 1 or a 2, that's 2 out of 6, which reduces to a 1/3. By that means we go to urn number 1. If we roll 3, 4, 5, or 6, then we are out of urn number 2. Which is 4 out of 6 probability. Reduces to 2/3 if you're going to stick with the fractions. And that means we go to urn number 2. Now, what happens if we go to the urns? We're looking for a black ball. So, out of urn number 2, we could either get black or we can get white. Probability of getting a black ball, well, 4 out of 7. Probability of getting a white ball, 3 out of 7. Okay? The other possibility would be if we went down here, urn number 2. Now you could get a black one, you get a white one, or you could get a red one. These are the possibilities of things that could happen. What's the probability of getting a black ball out of urn number 2? Well, that's 4 out of 13. Probability of getting a white ball would be 7 out of 13. And the probability of getting a red ball, which could happen, 2 out of 13. So there's what we got going on. Which, as you look at this, so we want the probability of getting a black ball, but depending on what urn we choose from, changes our probability. So if we roll a 1 or 2, we have a 1 out of 3 chance of getting this. And then, keyword, and then, we got to draw the black. So, what are we doing? Well, we're taking 1/3 times we want a black ball. We want that and that. Both of those happening. So as we multiply them together, we take 1/3. Why am I doing that? Because I want all the repeating threes. The calculator knows that. Times my 4/7. And our probability, I'm just going to go to 4 decimal places. That's one scenario that can happen. What's the other scenario? We roll a 3, 4, 5, or 6, which has this probability. We then still want a black ball, so 2/3 and that probability. So again, I want my calculator knowing that I'm using all of that. So 2 divided by 3, there's my 0.6 repeating, times 4/13 equals 4 decimal places again. Now, we're happy with a black ball by this scenario or that scenario, meaning what? Add the two probabilities together. 0.1905 plus 0.2051. We have about a 40% probability of getting a black ball. It just depends on which scenario we go based off of the roll of the die. Now, I said there's another way you could do this. Some of you might not take the time to draw all this stuff out. Okay, don't. Use your probabilities. Probability of getting a 1 or a 2, boom. And then we want a black ball from urn number 1, just got to know where the directions are taking us. Boom, you can jump right to that step right there. Likewise here, the rest of the roll of the die, 2 out of 3, there, you can jump to that. Just know that you're doing both of those and you're going to be adding them together. Okay, this next example, calculator company, 3 types of calculator. Calculator A, 15% of all of them made are A. Calculator B, 45%, and then calculator C, 40% of the market. Now, of these calculators, 2% of A are defective, 3% of B are defective, and 1.5% of C are defective. So, what's the probability of selecting a defective calculator? So, again, I'll start off with the mode of using a tree diagram. You don't have to. So, we need a calculator. There are 3 scenarios we could get a calculator. We could get calculator A, which is 15% of the market, so you got a 15% chance. Calculator B, 45% of the market, so you got a 45% chance of selecting that calculator. Calculator C is 40% of the market, so 0.4 there. Okay, so there's our 3 calculators. And then there's the defective, not defective. So I'll just use defective as D and D for not defective. So for our A type, 2%, so 0.02, and then 0.98 not defective. Calculator B, defective, not defective. Well, go back to here, 3%, 0.03, not 97% of them work all the time. And then calculator C, defective, not defective. Calculator C's got a 0.015 on the defect and 0.985 that work, not defective. Okay, so what do we want? We want a calculator that is defective. So if we choose A, that much of the market, there's how many of them are defective. So 0.15 times 0.02. Calculator B, 45% of the market, and we want the defects. 0.045 times 0.03. And calculator C, again, looking for the defects. So that's 40% of the market. That should not be there, that's a mistake. The decimal point should be right there. 0.4% of the market, and again, we're going defective, so 0.015. Again, did it say what type of defective calculator? No, it just said defective out of all of these. So we work. 0.15 times 0.02, 0.003, 0.45 times 0.03, 0.0135, and 0.4 times 0.015. It doesn't matter what brand gives us one. We're not assuming. We're saying we want a defective one, so it's an OR. When we get to this point, we add everything up. And we come up with an answer of 0.0225. Meaning what? You got about 2 1/4 chance of getting a defective calculator. Approximately 2 1/4. Why I say that? Because we rounded a little bit. And now our third example. Alright, so based off the U.S. Census, 21% of women are single, 57.6% of women are married, and 21.3% of women are divorced widow, based on the U.S. Census information. Of the single women, 7.1% unemployed, married 2.7% unemployed, and then the divorced widowed category, you got 4.2% who are unemployed. So obviously we're working on the unemployed portion of this. So find the probability an adult woman is unemployed. Find the probability an adult woman is unemployed. So unemployed is what we're looking for here. Now, some of you will jump the gun and figure this out right off the bat without doing a tree diagram. Good. Run with it and go with it. There's nothing wrong with that. If I set up a tree diagram, so we got women in the U.S. We've got them divided, according to the census of this particular problem here, in 3 categories. And they are single, which is 21.1% of the population of the women. They could be married, which constitutes 0.576, 57.6% of the women in the Census Bureau. And then they could be divorced / widowed, which according to the census, 0.213. All right. From there, what are your choices? They could be unemployed. They could be employed. Unemployed, employed. So of our single women, unemployed, 0.071, meaning 0.929 are employed. Married, same thing, unemployed, employed. So 0.027, meaning 0.973 are employed. And one more time, as we look at this, again, 0.42 of the divorced widowed, so 0.042, sorry. Unemployed, meaning 0.958 are employed. So our focus is the unemployed. So we start with women who are single, 0.211. We want the unemployed, 0.071. Probability of being single and unemployed. Probability of being married, 0.576, and unemployed, 0.027. Probability of being divorced, widowed, 0.213, and unemployed, 0.042. So as we look, clear. 0.211 times 0.071. So I'm going 4 decimal places. 0.01. As we see here, I don't know, maybe that's not on there. 1, 2, 3, 4 for you fans that forget rounding. Round up, can't keep a 10 here, so I take it up. 50. Next, 0.576 times 0.027 gives us, and again, we're going 4 decimal places, 0.0156 and 0.213. Again, percent divorced, widowed, and unemployed. 0.213 times 0.042. 1, 2, 3, 4. That 4 tells me we're good. It didn't ask for just unemployed single. Then that would be our answer. They wanted unemployed out of all of our categories. So now it becomes the or portion of it. And now we add everything up. 0.0150 plus 0.0156 plus 0.0089, and there we go. 0.0395, so about 4% with rounding. 4% chance of being unemployed based on the census. So we'll use that to help us again. Do you have to do all this part? No. If you can jump to that and do it, be my guest. Run with it.